In this video, we will see the design of beams. So the question discussed today is two channel of 180 by 80. So 180 is total depth of web and 80 is the flange width. Section with bend lips as shown in figure are connected with webs to act as beam. The thickness of the plate is 2.5 mm and the lip is actually 25 mm. The beam has an effective span of 4.1 meter. Determine the allowable load per meter run on the beam. Take Fy is equal to 235 Newton per mm square. So we know the basic design stress is equal to F is equal to 0.6 into Fy in the IS 801. As a clause 6, we have the allowable design stress F is equal to 0.6 into Fy is taken here. 0.6 into 235 will give you 141. And W by T limiting, as we discussed in the last video, that in our PDF in table 16.2 there are MKS unit as well as SI unit. So in SI unit for compression elements other than tubes, so in this beam member top will be under compression and bottom will be under tension. So we're taking the compression as a serious element because the steels are strong in tension, weak in compression. So the W by T limiting is given by 446 by root F used here. So we have 141, 446 by 141 will give you 37.6 W by T calculation. So W is the 80 minus these two corner values which we have seen in the last video. So deducting those, we will get 64 as the effective, like the clear width 64 divided by 2.5 thickness of um, the member 25.6, which is less than 37.6, so limiting value. So in that case, as the values W by T is here, just a minute, W by T value is less than W by T limit. So the first case, a full section is effective. That is, I'm so sorry. W by T value is 25.6, which is less than W by T limiting. So the this problem is actually wrong. So our condition is W by T up to W by T limiting as our, so the full section will be effective. We have to use full section as effective. So the value will be the 64 will be the effective width. Okay, uh, and so these things is actually wrong. We don't want to take this equations. If the W by T was greater than W by T limiting, then we have to go for this equation 658 by root f into 1 minus 145 by W by T into root f. So this is actually wrong, and so we got the W as 64 directly, and then those changes will happen. Yeah, here they have used that thing. The B is equal to 28.98 into 2.5. So 28.98 into 2.5 will give you 72.4, which is greater than 64. Yeah, so B by T is here to 28.98. So B is equal to T into 28.98, 72.4. So don't do these steps directly. We are getting B is equal to W is equal to 64, as we know it is fully effective. Then we have to find the I section, sorry, the moment of inertia of this section. We know that webs are there, we know the flanges are there. taking moment of inertia about the centroidal axis will give you this big value in mm raised to 4, and we know the bending equation. Section modulus is given by moment of inertia by y value, which is equal to 109.36, and the bending moment is equal to f into z, where f is the non value 141, and z we know from the previous value, and the value is 15.4 kilonewton meter is the moment capacity of the beam, and we can take it as simply supported W square by 8 is equal to the moment, and on solving we will get the W is equal to 7.33 kilonewton per meter. So the beam design is a simple uh, design work than the design of column. Okay, that's all for today.